any of the products of acrylic polymers in market. Okay. So can you tell me, or you can try to tell, otherwise we will move forward with some examples. Okay. Can you tell me acrylic polymers? Hello. Hello.
एक्रिलिक ग्लास जो होता है which is a like alternative to glass.
Yeah, which is nothing but the alternative to glass due to its transparency. It is looking like a glass material, correct? Yes, it is correct. Okay, okay, you have already told one of the example. Okay. So have you heard about PMMA, polymethyl methacrylate? I think in very first of few lectures, someone have mentioned about some acrylic polymers. I think he may not be there in lecture, or I don't know. Okay, but we'll start with this session first. So for before starting this lecture, we will take some revision of you. Okay, to just remind you all of the techniques, or not all of the techniques, but whatever the techniques used to synthesize or to prepare the acrylic polymers, or you can say polyacrylates. Okay. So generally, means majorly all of the acrylic polymers have been synthesized using your addition polymerization. Okay. All of you know about the addition polymerization. I think I only have took that lecture in starting session. Okay. Addition polymerization. All of you know about. Hello. Hello. There are two, we have studied two type of polymerization techniques. One is addition and second is condensation, correct? Okay.
Yes, sir.
Yeah. So out of which polyacrylic or acrylic polymers have been synthesized using addition polymerization. Okay. In addition polymerization also, we have seen three type of polymerizations. One is cationic polymerization, second is anionic polymerization, and third is free radical polymerization. Correct? So one by one, we will just revise the things. Is it okay to all of you to revise the techniques?
Yes, sir.
Okay. So first of all, the first type of addition polymerization is nothing but your cationic polymerization. Okay. If you are able to see all type of means many of majorly this unsaturation part or double bond part, whatever the monomer is having with us, it is nothing but the ethylene. Okay, which is used to synthesize your polyethylene, correct? Okay, so this kind of monomer in which unsaturation is present. Unsaturation is nothing but your double bond between your carbon-carbon atoms. Okay, so this kind of monomers will can be synthesized using your addition polymerization. Okay, so one of very first type of the addition polymerization is nothing but your cationic polymerization. My voice is clear to all of you?
Yes, sir.
Yeah. So for very first type of addition polymerization is nothing but the cationic polymerization. What do you mean by cationic first of all? Okay. Uh, what do you mean by cationic polymerization? Cationic means positively charged ion. Okay. Cation means positively charged ion. Have you seen here this H plus? Hello.
Yes, sir.
Yeah. This is nothing but the positively charged ion. Okay. Which comes from some catalyst. The catalyst which we use to synthesize polymer using cationic polymerization, from that this H plus will come. Okay. So how your polymerization reaction will get start? So can you observe here in this representation here? Okay. Now see whatever the catalyst present here, whatever the SO or HO in that way. This is nothing but your cationic free radical. See, whatever the positive charge, it will propagate your unsaturation or double bond, correct? And it is going to add one means whatever the monomers to it, correct? And this kind of polymeric chain will get formed. Have you seen that? Hello. See,
We
whatever
can
the
see here, sir.
yes,
Yes, sir.
yes, whatever the initiator, it will start the initiation reaction, and one by one, it will add monomers to it. Okay, by pushing the charge over next carbon. Correct. So this kind of polymeric chains will get formed using your cationic polymerization. Okay, what is the requirement? Your monomer should have unsaturation or double bond between your carbon-carbon atoms. Okay. So in acrylic as well, whatever the acrylic monomers are been there, we will see the structures of acrylic monomer in upcoming slides. Okay. Then you will understand how your acrylic polymers will get formed using this kind of techniques. Okay. So this is nothing but the cationic polymerization. Okay. Have you are you remember can you able to see this part or have you understand this?
We can see it, sir.
Okay, okay. All of you understand this part? Okay. We'll move forward for the anionic polymerization part. Similarly, as we have used cationic initiators, okay, cationic initiators to synthesize cationic means through cationic polymerization. Here we have anionic part. Have you seen this negatively charged part over here? Hello.
Yes, sir.
Yes, sir.
Whatever nothing but the Cl minus part, correct? Not just a minute. Don't know why. Okay. So whatever the negatively charged ion over here, which is act as your anionic part. Okay. Due to or it is responsible to initiate your anionic polymerization reaction. Here you can observe the things. Whatever the anionic part, this negatively charged part will attack on your next monomeric part. Whatever monomer coming towards the negative charge, it is having unsaturation or double bond to it. Correct. See, on this side, your monomers are coming, correct? Which
Yes, sir.
are having double bond. That double bond is getting break, correct? And forming the chain, correct? So this is nothing but your anionic polymerization technique. Okay. So next, the third type of addition polymerization is nothing but your free radical polymerization. Okay. So what happen in free radical polymerization? The initiator breaks into two parts. Okay. Here I have shown the general representation of it. Okay. If you see this red and green color, see whatever the green color, it is initiator. In presence of some heat or radiations, it will break into two parts. Okay. Whatever the first part, it will react with your monomer and other monomers will get added into it. Okay. And it will form a polymeric chain. Correct. This is nothing but a general representation. But structure wise, if you see that, okay, on this side, see, there is a radical initiator, okay, presented by a X and dot structure. Okay, it will come. Just wait, we will wait for it. Okay, see, these are the your monomers. This X dot is nothing but the whatever the initiator breakdown. Okay, then your monomers will get added to your free radical part. Okay, and accordingly your polymeric chains will get formed. Do you observe that? Okay. So this is nothing but your free radical polymerization. So whatever the acrylic polymers we are going to study now, all of the acrylic study means majorly all of the acrylic polymers will get synthesized using free radical polymerization technique. Okay. Just remember this thing. Many means majorly all of the acrylic polymers will get synthesized using free radical polymerization technique. Okay. All of you understand this part?
Yes, sir.
Yes,
Okay.
sir.
So we will start with our acrylic or acrylates part now after revising all of the things. Okay. So first of all, in introduction part, you can observe here the monomer structures of acrylates. Okay. Can you see this structure? This is nothing but a general representation of your acrylate structure. Okay. which is having unsaturation over here. Can you observe this unsaturation C double bond C?
Yes, sir.
Okay, this is the major part of your acrylate monomers, okay, which is again attached to this ester part. Okay, C double bond O and R. Okay, this is nothing but a general representation of your acrylate structure, which is further this R group. Okay, this R group, if this R is nothing but a hydrogen, then it will become your acrylic acid. Okay, see, if you can observe this, after replacing this R with H, it will become acrylic acid. Or if R we can replace with some ethyl or methyl group. Here we have replaced this R with some methyl group. This CH3 is nothing but methyl, correct? So it will become your methyl methacrylate. Okay, sorry, it will become your methyl acrylate, not methyl methacrylate, methyl acrylate. Have you seen this? This is the general representation of your acrylate first structure, correct? If you replace this R with H, it will become your acrylic acid. Okay, and if you replace this R with some methyl, then it will become methyl acrylate. Okay, this is nothing but the general
Yes, sir.
representation of your acrylic monomer system. Okay, so acrylics are polyesters based on acrylic acid or propionic acid part formed from the polymerization of alkyl acrylate esters. Okay, or we can again define it in a other way. It is like acrylic plastics refer to a family of synthetic or man-made plastic materials containing one or more derivative of your acrylic acid, or the similarly whatever the mention above, like acrylic esters. Okay, the most common acrylic plastic is polymethyl methacrylate, or generally we mm, in a regular base we called it as a PMMA. Okay, if you see many of the like we have discussed before, that number part, correct? 1 2 6 4 1 2 3 4 5 6 in that way, in that triangular shape, recycle whatever the recycle symbol is there. Okay, in that you can observe PMMA. Okay, that PMMA is nothing but your polymethyl methacrylate. Okay, the monomers are esters of acrylic and methacrylic acid, as we have seen in the structures. Okay, some common esters are methyl, ethyl, or N-butyl, isobutyl, or 2-ethyl hexyl, and octyl. Okay, so now I have mentioned some of the monomers which are generally used to synthesize acrylic polymers. Okay, if you are using acrylic acid, then it will be your polyacrylic acid or polyacrylate structure of your polymer. If you use methacrylic acid, it will obviously polymethacrylic acid. Okay, similarly, acrylamide, acrylonitrile, cyanoacrylates. These all are nothing but the raw materials which are being used to synthesis your acrylic polymers. Okay. Then again, what kind of things are there in acrylic polymer? Okay. Polymerization of the monomers occur by free radical polymerization. Okay. As we have mentioned in the free radical mechanism, many or majorly the polymerization of all acrylates or all acrylic polymers are by free radical polymerization technique. Okay, using free radical initiators such as azo compounds or peroxides. Okay, clarity and stability of their properties upon aging under the severe service conditions. It tends to be like soft and tacky, while methacrylate polymers are hard and brittle. Okay, you can observe, see, there are there is a range of product of acrylic polymers. Okay, if you see, like I will now mention here some of the examples. Okay, if you observe like Fevicol or whatever the bonds available in market to stick the woods, as well as the paper adhesives. Have you seen many of the paper adhesives in market, or you can say glues for the paper sticking? Hello.
Yes, sir.
Yeah. So that glues are made up of your polyacrylic polymers. Okay. Whatever the adhesives we are making for paper or wood, Many of them are made up of your polyacrylic acids or sorry, polyacrylic polymers or acrylate polymers. Okay. Then the if you see the nature of that, that are nothing but some sticky material. Correct. Okay. I'm like telling you about the range of polyacrylic or you can say acrylic polymers. Okay. It will start from sticky materials to hard materials. As one of you just mentioned, like it can be a replacement of glass. Correct. Okay. So we can synthesize or we can prepare poly or acrylic polymers structure like glass as well, and we can also prepare acrylic polymers structure like your glue or sticky material. Okay, now you understand what kind of range we can prepare from acrylic polymers. Hello.
Yes, sir.
Yes,
Okay.
sir.
Yeah, so that's why if you see the property wise, your acrylic polymers can have the properties of stickiness to hard material. Correct? That kind of range we can prepare from your acrylic polymers. Okay. That's why here third point is like it tend to be soft and tacky, while methacrylate polymers are hard and brittle. Okay. The vast majority of commercial available acrylic polymers are copolymers of acrylic and methacrylic esters. Okay. Copolymers, all of you know about now. Yesterday also we have repeated about the homopolymer and copolymer, correct? Yes. So the polymerization can occur by bulk solution, emulsion, and suspension methods. All of these four methods can be utilized to synthesis or to prepare the acrylic polymers. Okay. The suspension grade polymer is used for molding powders. Okay. Whatever the polymeric powder will get out of the acrylic polymers using suspension polymerization, we can use it for molding purpose. The emulsion and solution grades are used for coating and adhesive purpose. Okay. So the very first polymeric type under acrylic polymers is nothing but your polymethyl methacrylate, or we can call it as a PMMA. Okay, as we just now mentioned it about. Okay, so which kind of monomer is used for preparation of your polymethyl methacrylate, or we can simply call it as a PMMA. So can you able to see the structure over here?
Yes, sir.
Okay. This structure is nothing but the repeating unit of your PMMA. Okay. This consists of this long chain. Okay. And this is nothing but the pendant group, or you can say functional group over here. Okay. If you repeat this again and again, you will get the long polymeric chain over here of PMMA. Okay. The most important member of the acrylic polymer is PMMA. PMMA for molding or extrusion is produced commercially by free radical initiated suspension or bulk polymerization of methyl methacrylate. PMMA is an amorphous polymer composed of linear chains. Okay. What happened due to this amorphous nature? Yes. Can you tell? Due to this amorphous nature, which property we will get? Okay. Everyone, please focus on this. Like due to the amorphous nature, main property we will get is nothing but your transparency. Okay. All of you know that one of you mentioned the example of acrylic polymers is nothing but replacement of glass, correct?
Yes, sir.
Sorry. Replacement of glass. So glass have property of your transparency, correct? So why glass is transparent due to its amorphous nature. Okay, due to its amorphous nature, glass is transparent. That's why if you see the very first property of your methacrylic or PMMA, it is nothing but the amorphous polymer composed of a linear chains. Okay, due to this amorphous nature, it is having transparency. Okay, the bulky nature of the pendant group, whatever the pendant group is nothing but this from this carbon. Can you able to see this? This is nothing but the pendant group. Due to the bulky nature of the pendant group and the absence of complete stereoregularity, makes PMMA an amorphous polymer. Okay. So all of you understood about the amorphous nature of PMMA? Hello.
Yes, sir.
Okay. So we'll move forward. What all properties PMMA have? Okay. Can you observe these applications of PMMA? Many of the PMMA, like here I have mentioned, these are nothing but the PMMA sheets that are transparent. Okay. If you see these articles over here, all of the articles are transparent. Correct? If you add some color, then also they are transparent in nature. Can you see this?
Yes, sir.
Okay. So it is a hard, clear, colorless, and transparent plastic. Okay. What all properties are there? Hard, then clear, colorless, and transparent plastic that is usually available as molding and extrusion pellets, reactive syrups, cast sheets, rods, and tubes. Okay. These are nothing but some applications of your properties and application of your PMMA. Then PMMA is characterized by crystal clear light transparency, unexcelled weatherability, and good chemical resistance and electrical and thermal properties. Okay. It has a useful combination of stiffness, density, and moderate toughness. So what is exactly the TG? TG is nothing but the glass transition temperature. As I have discussed, I think before one or two lectures to you, glass transition temperature is nothing but the temperature below which your polymer will act as a hard or glassy type of material, and the temperature above which your polymer will act as a rubbery or flexible. Okay. Have you remember that part? Hello.
Yes, sir.
Okay. TG is nothing but your glass transition temperature of your polymer. Okay. So PMMA has moderate TG of nearly 105 degrees Celsius, 105 degrees Celsius. A heat deflection temperature in the range of 74 to 100. Okay. And a service temperature of about 95 degrees Celsius. Okay. These are nothing but the thermal properties of your PMMA. Okay. The outstanding optical properties of PMMA combined with its excellent environmental resistance recommend it for application requiring light transmission and outdoor exposure. Okay. Due to its clarity or transparency, we can use the PMMA in applications where light transmission means passing of your light rays, okay, are been there, and outdoor exposures. Okay. All of you understand about the properties and applications of polymethyl methacrylate or PMMA?
Yes, sir.
Okay. Any doubt is there? Hello. Till now, any
Right now,
doubt is
no.
there in lecture?
No, sir.
Okay. So we'll move forward. What all uses of polymethyl methacrylate? Okay. So can you able to see in very right side, there are some eye lenses. Okay. Have you seen these lenses?
Yes, sir. Is it
Okay.
made up of acrylic?
Yeah, these lenses are nothing but the product of your acrylic polymers, and majorly PMMA, polymethyl methacrylate, have been used for this. Okay. So this is one of the application of your PMMA. Polymethyl methacrylate is used for specialized application as a hard contact lenses. Okay. The hydroxyethyl ester of methacrylic acid is the monomer of choice for the manufacture of soft contact lenses. Both kind of contact lenses are available in market over there. Some of like flexible. If you see, many of the contact lenses are flexible in nature. If you change your or if you alter the monomeric system, like for PMMA, we are using methyl methacrylate monomer, correct? If you use some monomer which can produce flexibility to it, okay, which is nothing but your hydroxyethyl ester of methacrylic acid, this kind of monomer will create flexibility in your PMMA polymer. Okay, that kind of polymer we can use for soft contact lenses. Okay. Hello, have you understand about
Yes, sir.
the application of this PMMA in contact lenses?
Yeah.
Okay. So next is like other applications of your polymethyl methacrylate are nothing but it these typical applications are like in construction. Okay, in construction, if you see enclosure for swimming pools, shopping malls and restaurants, tinted sunscreens, okay, to reduce the air conditioning and glare, domed skylights. Have you observed these parts?
Yes, sir.
Okay. Many of you may think like these parts can be made up of your glass. Okay. Whatever the shopping malls and restaurant that transparent sheets are there, correct? That are majorly like if you see if there is a use of polymer, then that polymer must be like PMMA. Okay. Then in lightning
You
of
mean to say that
applications,
all building glass are PMMA only?
yeah, may see. It depends on the application, like whatever the purpose. Okay, they might be your PMMA as well as many of the buildings glass have been used. Okay, but nowadays in many of the applications, like many of the parts, PMMA sheets they are using. Okay,
What is the advantage of using PMMA compared to normal glass in buildings?
if you see toughness of it, like if your glass have been attacked by something sharp material, correct? Okay, the whole of your glass will get break, correct, due to its extreme hardness. Okay, flexibility is not there with your glass material, correct? But if you
Yeah.
see PMMA sheets, okay, if you heat PMMA sheet with some sharp material, it will get cracked, but not like your glass material, okay? Or whatever the harm will create due to your glass material, that will not create due to your PMMA material, okay? Again, then the whatever the light absorbance or whatever the other properties, if you want like retardation of your sunlights or UV rays. Okay, that properties can be impart in your PMMA sheets. Okay, it can work as a shield. Okay, what are the sunscreens available over your tinted sunroofs? Correct, that are also made up of your PMMA sheets. Okay, so
Yes,
second.
sir.
Okay, so second application is in nothing but is your lighting system, lighted signs or luminescence ceilings or diffusers, lenses, and shields. In that applications are also PMMA have been used. Okay. Then automotive. If you see in recent slide, I have mentioned here one photograph. Okay. Have you seen this photograph of light shield? That is nothing but your PMMA made up of PMMA lenses, instrument panels. Okay. Then signals, whatever the sheets used over your signal lights, okay, that are made up of your PMMA again, okay, and nameplates, okay. Then aviation, windows, instrument panel, again lighting fixtures, radar, plotting boards, canopies, okay. In household, what all applications are there in household? Okay, room dividers. Have you seen the room dividers? Mean if you make some partition over your room, in many of the partition, glass are being used. If you want to use alternative to your glass, you can use PMMA sheets as well. Okay. Then decorating applications, furniture, vanities or tubs. Okay. In this kind of application, household applications, PMMA have been used. Okay. Other applications of PMMA are nothing but the display cabinets and transparent demonstration models in museums. Okay, all of you understand about whatever like again if you see the pictures over here, mobiles have been presented, correct? So whatever toughen glass you are using on your mobiles, correct? Toughen glass or glass
Yes,
protection you are using, that thing is nothing, not a glass, but it is a PMMA sheet. Okay, hello.
yes, sir.
Yes, sir.
Toughen glass means glass is also available in market to protect your whatever the mobile things are there, but whatever the flexible things are getting, okay, that are nothing but your PMMA sheet. Okay.
Can we use this PMMA in windshield glass car?
Yeah, we can use, but whatever the properties, it is again dependent on your polymeric properties again.
Yeah,
Okay.
but as per your knowledge, are you using currently?
No, 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 not in regular cars. Okay. But if you see lightweight cars, wherever the lightweight applications are there, okay, in many of the like, if you see the army applications, okay, whatever the army applications are there, okay, that shields, bullet shields. Have you seen bullet shields?
Yeah.
Okay, in army application, not I'm not saying that you have seen this, but in photographs, pictures, or videos, bulletproof sheets or bulletproof things are there, transparent, correct?
Yeah, armored vehicle. Yeah.
Yeah, in armed vehicles. So that bulletproofs can be made up using PMMA, not exactly PMMA, but the composite of PMMA. Okay, composite of it using some other materials. Okay, that materials can be used as a shield. Okay. Again, if you see like whatever the helmets we are using, correct? So that helmets have that transparent part in front of your face, correct? Hello, hello.
Yes, sir.
Yeah.
Yes, yes, sir.
So that many of the in many of the parts like PMMA can be used over there. Okay. So what other things you can be observed in polyacrylates? This is nothing till now. This is nothing but your PMMA or polymethyl methacrylate. Okay, which is nothing but one of the replacement of your glass, correct? Which is nothing but hard in nature, transparent, okay, tough, okay. These are nothing but the applications and properties of your PMMA plastic, or you can say polymethyl methacrylate plastic. Okay, so what other plastics can be made out of your polyacrylates, or what other type of polyacrylates are been there for the study? Okay, so let me ask you about like, have you seen some kind of material like magic balls? Hello.
That from water.
Yes. What?
The one that absorbs water and swell up.
Yeah. Correct, correct. Whatever the magic balls are there in market for playing to children, like to means for that children's purpose. Okay. What is their properties? If you add that magic balls in water, correct? So that magic balls will absorb the water and the shape will get increase. Correct? Correct? Hello.
Yeah, correct, correct.
Yeah, that is the property of that magic balls. What very tiny size is there before adding in water. That tiny size or that very you can say particle, that particle if you add in water, it will absorb the water and it will become some large size ball.
So
Correct?
that is made from this
That is nothing but your
polyacrylates.
polyacrylate polymer.
Okay, great.
Okay. That made up of your polyacrylate. Just the thing is like what your monomers have been used over there. That monomers are different. Okay. What property exactly that is? That is the absorbance of your water, correct? It is nothing but the super hydrophilic. Hydrophilic means water loving. Okay, hydrophilic is nothing but your water loving part. Okay, so whatever the functional groups which absorb the water are nothing but your acid, amide, in that way. Okay, acid, hydroxyl, amide. See here, you can observe here, this is nothing but your carboxylic functional group, correct? COOH. We have studied this carboxylic functional group in your polyester part. Do you remember that?
Yes, sir.
That acid functional group is nothing but hydrophilic, or that can water lovable part. Okay. Similarly, if you observe only hydroxyl group, okay, if you observe only hydroxyl group, that hydroxyl also hydrophilic in nature. Amine, if you if you remember amine NH2, that is also hydrophilic. So this kind of functionality, whatever the monomers, acrylic monomers, which have this kind of functionality, that monomers have been used to synthesize polyacrylates, which are nothing but for the water absorbers. Okay. So polyacrylates are produced commercially by free radical initiated, as we have seen, and emulsion polymerization of the appropriate monomers. Glass transition temperature of of acrylate polymers are generally below room temperature. Okay. Now you will see that what glass transition temperature we studied in a recent slide. Have you remember that for PMMA? What is the TG over there?
105.
Yes, it is 105. It is above 100. And what is this statement here? Glass transition temperature of acrylate polymers are generally below room temperature.
Sir,
Correct?
your voice is very feeble, sir.
Hello, now it is clear?
Yes.
Yes, okay.
Yeah. So can you able to whatever I said, I have you understand that part?
Yes, the glass transition temperature of acrylic polymer are below
Yes, yes.
room temperature.
Yes, yes, yes. In recent slides, we have seen that glass transition temperature of your PMMA, polymethyl methacrylate, is nothing but 105 degrees Celsius. Okay. So from these, what do you understand here? It is like we can prepare polyacrylates from minus glass transition temperature to some of hundreds. Okay.
Sir,
If you,
one doubt. You
yes.
told it is used in a windshield application where it is very hard. So maybe it's a crystalline form. And the
No,
other
no,
one
no. It
what
is
you
not a
told is
crystalline form. It is a amorphous form.
even that is an amorphous only.
Yes.
But it doesn't change its shape, no. And normally amorphous means it can get reacted, we said, but windshield will not react on only the sponge that
Windshield can also
magic
change
ball.
its shape. See, see,
Oh,
see. First of all, we will clear the example of windshield. Okay. If you
uh,
see the windshield, it is hard in nature at room temperature, correct? So
yes.
what glass transition temperature we have mentioned in case of polymethyl methacrylate, it is nothing but
105.
105 degrees Celsius, correct? And whatever the heat deflection temperature over here I have mentioned, okay, it is nothing but 74 to 100 degrees Celsius. But whatever windshield, okay, windshield till what temperature it will go? Whatever the windshield
Uh,
application is there,
normal,
normal like room
normally it will
temperature
be
or nearly in summer session, you can consider it
45
as
to
a
50 degree
45 to 50
maximum.
degrees Celsius, correct?
Yes.
It will not be affected. If you see the service temperature here, service temperature is about 93 degrees Celsius, but we can consider it as a 74 for now. Okay, as heat deflection is start at 74 degrees Celsius, correct? Till 74 degrees Celsius, it will not affect its shape. Okay,
Okay.
but after that, it will get deflected. Whatever the polymeric change or whatever the polymer, it will get deflected due to the heat after your 74 to or 100 degrees Celsius, you can say, as it is its glass transition temperature is 105 degrees Celsius. At 105 degrees Celsius, its shape will get started changing. Okay, but till that temperature, whatever the shape is there, it will constant. Okay.
Okay.
Okay, so now what you asked about the this magic ball or hydrogel.
No, if it is changing means it is amorphous, it will react with the moisture. Huh?
Amorphous, not every amorphous material will react with your water part. Okay, see, amorphous is not like water absorbance. That is the different thing. If you are having functionalities or functional groups which absorb the moisture, then only amorphous polymers can water sensitive. Okay, not all amorphous polymers are water sensitive. Okay,
Okay.
it completely depends on its structural properties or structure of your polymer.
Uh,
Okay.
Previous understanding was if it is crystalline, it will be harder. If it is amorphous, it will be little softer. That is why
Yeah.
I confused.
Yes. Yes. Crystalline is obviously hard material, but if you see the this polymethyl methacrylate is you can say semi-crystalline, but crystalline portion is very low in your polymethyl methacrylate. All of the polymers are semi-crystalline, that you all know about.
Yeah, yes.
Okay, semi-crystalline, just the part, like how much crystalline it is. So whatever the polymethyl methacrylate is less crystalline. Okay, it
Oh,
is more amorphous in nature. That's why it will have transparency property. Okay,
okay.
so for that PMMA, it was clear for you. Then now, what is the doubt for this hydrogel or this magic ball?
No,
So one question from my side, sir.
Yes,
If that polymer is transparent, that will be amorphous material.
yes,
So PC will be also amorphous only.
yes.
It will not be classified in semi-crystal or crystalline.
It is a semi-crystalline, but amorphicity is more in that case.
Okay.
All of the polymers, whatever the polymers are there, are semi-crystalline in nature. Okay, semi-crystalline is
Okay.
what? The mixture of your crystalline and amorphous part. Correct?
Okay.
That can be in various percent. Suppose one of the polymer is present like 80% crystallinity in it, but whatever the remaining 20%, it is nothing but the amorphous nature. Okay, in that way. Suppose second polymer, if you take any of the example, if it is having 50% crystallinity, then remaining 50% is amorphosity. Correct? In that combination, your polymers are there. Okay.
Okay.
If someone tells you like this polymer is amorphous, then you can consider it as a semi-crystalline only, but amorphous nature is more of that polymer.
Okay.
Okay, if someone tells you like this polymer is if this polymer is crystalline, then you can consider it as like the crystallinity is more for this polymer, but amorphous nature is there.
Okay.
Okay,
Yeah.
yeah. So who asked me like which doubt is there regarding this
Sir, your
hydrogel or
voice again feeble, sir.
yeah, which doubt you have asked about the hydrogel or this part?
Uh, that magic ball,
Yeah, yeah, yeah.
it is picking the water.
Magic ball.
Yes,
Uh,
yes.
whether it is reacting or it is just porous or picking, it's like porous because of the porous capillarity, it is picking mechanically the water and again
Okay,
it will let out.
okay, okay, okay. So if you see, like I have mentioned here some of the examples of monomers, correct?
Because
Okay.
doubt because sponge is also picking that. That is why.
Yeah, yeah. Sponge is physically picking your water part. Okay.
That's
If
why
you
that.
if you if you pick water in your sponge, okay. If you put that sponge over some table or some surface, okay, due to
Mm,
the gravity effect, that water will get removed out of that sponge after some time. Correct?
yes, yes,
Yes. But that is physical activity. Due to that pores, it will pick the water. Correct? But
yes,
sponge size will not get changed. Correct?
yes,
Sponge size will be constant throughout the process. Correct? But here,
yeah,
if
yes,
you observe that particle size, that particle size magic ball is there, and after addition of water, that ball size will get increased. Correct?
yeah, yes,
So there is a difference in size. Okay, this is not
yes,
the adsorption of water due to your porous nature. Okay, that thing is clear first of all. Okay,
yeah,
so
yes.
why this absorption is there? Correct. So if you see the structure, as I have mentioned here, hydrophilic nature. Okay, hydrophilic is nothing but water loving part. Okay, hello.
Due to
Which
O-
portion?
due
Which
to OH
portion is
group,
hydrophilic?
Yes,
polyacrylic acid is a hydrophilic, right?
yes, polyacrylic acid.
And that
Okay,
due to OH group, that
due
hydrophilic
to
nature.
due to carboxylic functionality. See, I will tell you the examples of hydrophilic functional groups first of all. Okay, so as I have just mentioned now, carboxylic acid, this is nothing but the
COH.
functional group. Okay, COH, this is carboxylic acid. Again, if you see hydroxyl, hydroxyl is nothing but OH. Correct. Then again, if you add on the example of amine, amine is nothing but NH2 or NH. Correct.
Ah,
Yes. Yes. So these are some of the examples of functional groups which are generally present of your monomeric system. Okay, that are generally what generally having the property of water absorption or moisture absorbance. Okay.
Okay.
Yeah. So due to that chemical structure, your polymer is able to absorb the water. Okay. That's why we will get that water absorbency property over there. Okay. Whatever the magic balls are there, that in general form we are called it as a magic ball, but in scientific way we called it as a hydrogels. Okay.
Sir, actually, whenever in the previous cases, whenever we have a bonding or something, the H2O will it will react and let the H2O go out. In this case, it is taking the H2O in. Whether the H2O will break and get the hydrogen and oxygen separate.
See, in that case, whatever the like, if you consider polyester part, correct? Simple reaction we will take. In polyester, what will happen? We have carboxylic acid with us, okay, and hydroxyl, correct? Whatever
Yes.
the carboxyl is there will get react with your hydroxyl, will form ester linkage, and water molecule will get evolve as a byproduct. Okay,
Yes.
that chemistry is making the ester linkage. Okay,
Okay.
if you see here these carboxylic part will abstract whole water.
Water
Okay.
it will absorb and it will keep as H2O, or it
Yes,
will
yes,
change it as
it
some
will
other
keep
thing.
at it will keep as H2.
Okay.
Okay. That's why it will increase its size due to that presence of H2O molecule. Okay.
Okay.
Whatever the polymeric size. Okay. So that example we called it as a hydrogel. Okay.
Okay.
Whatever the magic ball I have mentioned here. Okay. That is nothing but your hydrogel. Scientifically, we called it as a hydrogel. Okay. So where these hydrogel applications are there? Uh, have you know about these hydrogels before or not?
I think whether these are all part of boat.
No. Okay. So in medical and agriculture, in drug delivery system, these kind of hydrogels have been used. Okay. So medical, it will be hard to understand, but we will understand it to agriculture part. Okay. If you see nowadays in modern agriculture system, I'm talking about modern agriculture system. If you see, see, we will consider that same example of magic ball. Okay. Hydrogel, we called it as a, okay. If you take that particle, okay, that hydrogel particle, if someone has impart some drug or you can say fertilizer in it, okay. Hello.
Yes, sir. Yes, sir.
Yeah. Okay. Suppose someone has introduced some fertilizer molecules or some fertilizer part in that hydrogel. Okay. If you increase the size of that hydrogels with the help of water absorption, correct? Water absorption will increase the size of your hydrogel. Okay. And if you put that thing over the over your crops in soil, correct? If you put that water absorb part in soil, correct? What will happen over there? Yes. So
It
in
will
that
be
case,
water.
yes, in that case, whatever the soil near your crops, it will pick that water part, correct? But it will not immediately pick that water part. Timely, like whatever the control release. What is control release? Your release of that water in your soil near your crop, it will be in a controlled way. Like in first minute some 1 or 2 ml will get released, in second minute 1 or 2 ml will get released, correct? In that way control release of your water and fertilizer with water, what are the fertilizer we have added before in your particles, that fertilizer will get added in your soil, correct? Have you understand this part?
Yes,
Yes.
sir.
Okay. In that way, in control release drug delivery or fertilizer delivery, we are generally use this kind of application of your hydrogels. Okay. So this is nothing but one of the example of your polyacrylates. Okay. Have you understand about that example? or that application?
Sir, water is released, you told, but where this gel is there?
Gel, gel. You can't take it like word wise. Hydrogel. Hydrogel means how we can say like gel. See, we are having first powder with us. Normal powder, solid powder. Correct?
Yes, sir.
Okay. If you put that powder in water, okay,
Okay.
that powder will absorb all of the your water. Correct? This is clear.
Okay.
After absorbing the water, it will look like a gel. Correct?
Yeah, yes.
Yeah, that's why it called as a hydrogel. Hydro means your water and gel means your that kind of texture or nature. Okay, that's why that name is there, hydrogel. Okay,
Okay.
okay. Gel is nothing but that.
No, no.
Yes,
Actually, during the fertilizer thing, water has to go for the plant and fertilizer has to go to the plant.
yes, yes,
You told we are using these things in that application, but water and fertilizer has to go to the plant, no? It has to go
yes,
to the
yes.
soil, it has to immerse in the soil, then only the plant
No,
can
no, 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 no.
survive.
See, yes,
Where the,
from soil only that part will go to your crops.
yes, but where our polyacrylic plays a role in that.
Yes. So whatever the hydrogel is nothing made up of your polyacrylates only. That is clear.
Yeah, yes.
Yes. So whatever the suppose in one pot you have to that polyacrylate or hydrogel powder. Correct? Okay. Hello.
Sir.
Yeah. In one pot we have take polyacrylate that hydrogel powder. In one pot you have mixture of your fertilizer and water. Correct?
No, yes, sir.
Okay. If you mix that water, mix that mixture of water in your that powder, so that powder will soak all of your water. Correct?
Yeah, yes.
And that soaked material if you put near your crop, okay, that
Mhm.
soil will absorb that or that soil whatever the water with fertilizer will get released timely. Okay, nowadays what traditional method is there? You will just add it in water or directly you can put it in a soil, whatever fertilizer is there. Correct?
Okay.
Okay, but that is at one shot you are adding it.
Yeah,
Correct?
yes. Yeah,
Okay,
yeah.
but
Actually,
with
this coconut, this thing, they used to, the coconut, above the coconut, there is a layer, no, that normally in a practical, conventional way, they used to keep that. It will
yes,
absorb the water and slowly it
yes,
will reach to the soil.
yes, yes, yes,
This is,
correct. This is
is a
conventional way.
it's a conventional and this is a synthetic
Yes, this is synthetic. This is more proper in short you can tell it as a because
concept.
timely it will release your water and yes, timely
Understood.
it will release the water and your fertilizer part. Correct?
Understood. Understood. Yes, sir.
Yeah. Yes. Any other doubt is there?
No, sir, we can go proceed next.
Okay. 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 So these are the like major examples as we have seen hard, very hard material like glass. Correct? And second one is like hydrogel. Okay. This much difference is there in your polyacrylates part. Correct? If you see here, range of glass transition temperatures have been given. Okay. This means that these polymers are usually soft, rubbery to hard materials. Correct? Okay. Here in table, I have mentioned some of the glass transition temperatures of some acrylate samples over here. Okay. Like if you use some methacrylic or in that way, then you will get the TG of nearly 3. It is also, these all are below your room temperatures. But as we have seen before in before 2 slides, that glass transition temperature of your PMMA, it is nothing but like 105 degrees Celsius. Correct? Yes. Okay. So we will just take a break of 5 minutes here. Okay. Will it be okay for you?
Okay, sir.
Yeah. We will start again after 5 minutes. Hello. Hello.
Yes, please.
Yeah. So good evening again. We'll restart our lecture. Okay. So let me share the slides first. Okay. So slide is visible to all of you. Yes. Hello.
Yes, please.
Yeah. So we have studied now the difference between in very broad range. We are having acrylic polymers with us. Correct. Okay. So what all things you have understand from it, like from glass transition temperature below room temperature to higher temperature, we are having range of acrylic or acrylates. Correct. So if you see here, like glass transition temperature, so since -56 means it is in a flexible form again. Okay. So which flexible applications we are having for polyacrylics? Now we have seen the tough or hard application like PMMA sheets. We have seen hydrogel type of application. Then the next is like properties of polyacrylates. Solubility in oils and hydrocarbons increases with increased length of the side group, while polymer become harder, tougher, and more rigid as the size of the ester group decreases. Okay. So why this range or why this broad range of acrylic polymers are there? It is due to the chain length of your polymeric system. Okay. Whatever the hydrogels are there, hydrogels are nothing but the low molecular weight compound. Okay. And whatever the polymeric system in nothing like polymethyl methacrylate PMMA, it is your high molecular weight system. That's why that properties are there. And again, whatever the functional groups I have explained, correct. So solubility in oils and hydrocarbons, or you can say hydrocarbon solvents, is there for your acrylic polymers as your side chain group. Side chain group means which? This one. Have you observed this? Okay. Hello.
Yes, sir. Yes, sir.
Yeah, this is nothing but my voice is clear to all of you, no? Yeah. Okay. So that is nothing but your side chain group. As your side chain group size will get increased, or sorry, as your side chain group size will get decreased, it will become more rigid or tougher or harder. Okay. So
Size means how, sir? That equation is
size means, see, as we are having here, if you see the structure of your this like PMMA. See here the structure of your polymethyl methacrylate is there, correct?
yes.
Okay. Here, if you consider the side chain or side group, which side group is there? This one, correct?
Yes.
C double bond O OCH3. Okay. If you
Okay.
replace this CH3 with some long chain,
Okay.
like here only methyl is there, correct? If you
Okay.
introduce here some butyl like CH3 or CH2, 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 CH3 in 4 carbon way, correct?
Okay.
In that way, if you increase the size, your toughness or flexibility part will get increased.
Flexibility.
Okay. If you decrease the size, your rigidity will get increased.
Okay.
Okay. I understand this part.
But anything can be bonded to that, or it is only benzene we
Uh,
have.
it can be benzene, but it depends again. If you use benzene, it become again rigid only. If you add some long chains, I'm asking about long chains, then it will get flexible.
Anything. What are all things to be added for softening?
Softening, like, see, we have mentioned here some monomers, correct? Have you
Okay.
seen this? All of the monomers. Okay. If you observe here, general representation of monomer, this R group, correct?
Yes.
If this R group is some long chain, like here in methyl acrylate, this R group is only the methyl CH3, correct? If you
O-
replace this R group with some long chain, like methyl butyl, sorry, not methyl, butyl or something else, long chain, correct? In that
Okay.
way, your flexibility will get increased.
So butyl will increase the
Yeah,
flexibility.
generally, if you want less TG, okay, what are the copolymer? Copolymer is what? Mixture of your monomers, correct? Two or more monomers.
Okay.
Okay, repeating unit, whatever the repeating units are there, it should be more than 2. Then only the copolymer system is there. Whatever the polyacrylates or co co copolymers of polyacrylates, in that way, there are, suppose you are using acrylic acid, methyl, methyl methacrylate, and suppose
Voice
butyl
is
acid.
feeble, sir.
Hello.
Now, okay.
Okay. Suppose you are using 3 type of monomers like methyl methacrylate, acrylic acid, and butyl acrylate. Okay. So in these three of like butyl acrylate is having that long chain structure. Okay. If you use butyl acrylate in more amount, then your polymer will get some flexibility to it. Okay. That's why that combination of monomeric system or the percentage of that monomeric system will decide the glass transition or whatever the flexibility or rigidity of your polymer. Okay. Yes.
Sir, then what was that in the gel? What was the additional this thing was there which has created it softer?
It is not soft. If you see the particles, okay, if you see the particles, it is a low molecular weight compound first of all. Okay. If you see the monomers, only this kind of hydrophilic groups are there, correct? As here carboxylic is there, correct?
Yes, sir.
But if you see the particles that are hard only, if you see magic balls over here, it is like a powder, or you can say crystalline powder in that way, correct?
Yes.
After adding water, it will get soft.
So water will be the side chain then.
No, no, water is not the side chain. Side chain is here only, that acid and all. After adding, obviously, if you add water in your wheat flour, correct?
The
Wheat
chain
flour
length
is
gets
there.
increasing, no, by adding the water.
Yes,
That is a, logically if the chain link increase, you say that it will be
that
softer.
is for only the polymeric structure I am talking about. Whatever the hydrogel, it
Okay.
absorb the water. Then after absorbing water, it will get soft
Okay.
due to water.
Okay.
But if you talk about only the polymers, then in
Okay.
that case, this thing is there.
Okay. So butyl is what make it soft. Correct.
Yes, yes. What are the long chain available on your butyl acrylate structure? It will be responsible for the softness or the
Okay.
flexibility part. Okay. So it is also known for their high transparency, good impact toughness as polyacrylates properties. Okay. Quite frequently, copolymerization is used to optimize the properties of polyacrylates. As I have just mentioned, whatever the monomeric system you are using, whatever the percent of monomers you are using, that is responsible to optimize the properties. Like if you want some hard material, then you obviously will use some short chain monomers. If you want some flexible, you will use long chain monomers, correct? Okay. So for example, copolymer of ethyl acrylate, here I have again mentioned the examples for your better understanding. Okay. So for example, copolymers of ethyl acrylate with methyl acrylate provide the required hardness and strength. Correct? Okay. Methyl acrylate is nothing but, again, if you see the structure over here, this is methyl acrylate, correct? Okay.
Okay.
Only methyl is there. Okay. Due to only the single carbon chain, the hardness will get there to your polymer. Okay. So
Okay.
copolymer of methyl and ethyl acrylate will give you the
Can you
hardness and
can you
strength to your,
move to the introduction, please?
yes.
Can you move to the previous slide introduction? Just now you shown that now.
Yes. 1 minute. Yes.
Yeah, this one.
Yes.
This is a milky type.
This one, no?
Yeah, image showing a milky type kind of.
Yeah, yeah. That example is next to our next point. Okay.
Okay, carry
Then
on.
we will come back to this again. Okay. Just remind me. Okay. If I forgot.
Okay.
Okay. So using this methyl acrylate and ethyl acrylate, we will get the hardness and strength to your polyacrylate system. Okay. This is clear to all of you?
Yes, sir.
Okay. So the next is like, while small amounts of co-monomers with hydroxyl, carboxyl, or amine and amide functionalities, as I have mentioned in your hydrogel part, correct? These all functionalities I have mentioned in your hydrogel part, okay, are used to produce high quality latex paint and wood, high quality of latex paints for wood, wallboard, and masonry in homes. Okay. So whatever paints we are using, have you heard about acrylic paints,
Yeah, yes.
distemper?
Yes, yes.
Okay.
Acrylic paints.
Yes, whatever that paints we are using have polymeric systems or polymeric emulsion system, as we have seen this picture over here. Okay, this one, correct? This is nothing but your paint. Okay, and we are using that. Have you
Basically,
remember?
this is the base paint, right? Kind of a white. Then we are
Yes, yes,
adding
yes. This is
coloring.
base paint. Yes, yes, correct.
Yeah, yeah. I got it because I did.
Obviously, whatever paint you will purchase from market, it is having white base, and generally we are adding some tinting, or we can call it as a pigment
Color
tinting
matching
mixture.
kind of.
Yeah, color matching. That tinting we have added, and we will prepare the color out of. That is the part of your coating again. Okay, but whatever the polymer used in this paint base, that is nothing but your acrylic emulsion. Okay, we have studied the emulsion part, means emulsion polymerization. Okay, do you remember that part? Emulsion polymerization. Okay, whatever the product we will get from emulsion, it is in a liquid form. It is not like the polymer is in a liquid form. The product is in a latex or liquid form. Not a liquid, but you can say it is like a milky type. Correct? Okay, that milky latex we generally used in paint application. Okay, hello.
Yes, sir. Yes, sir.
Yes, sir.
So that latex have applications in your household paint, or you can say architectural paints, whatever indoor outdoor paints we are using, whatever the distemper and all we are using. In that, the polymeric system which has been used is nothing but your acrylate polymer in emulsion form. Okay, so this is one of the application of your polyacrylates, which all applications till now we have observed. Yes, can you tell me
Sir,
examples of?
this is a
Yes.
UV resistant. This will have a UV resistance, no?
Yeah, it again depends on the combination of monomers. If your monomers will give the property of UV resistance, so it will be a UV resistance. Whatever the paint property will get, as you are talking about like UV resistance, it will get
Uh-huh.
due to some additives which we used in your paint system.
Okay.
Okay. Yes. So what all applications we have seen till now for polyacrylates?
Glass, car
Uh,
tempered glass, that front
yes.
glass.
Yes.
Then magic ball,
Yeah, you can call it as a hydrogel.
hydrogel.
Yes.
Then fiber type, which is used in agriculture.
No, actually, that whatever the agriculture example I have given to you, it is nothing but the hydrogel. Fiber we will see in next slides. Okay.
Okay.
Now we have seen the example like latex paints or latex, whatever the liquid latex of your
Hmm.
polyacrylate. Okay. This
Okay.
is the third example. Okay. In these functionalities provide the adhesion and thermosetting capabilities required in these applications. Okay. So one of application we have seen adhesives, correct? Paper adhesives.
Yes, sir.
Okay, paper adhesives. Which one you can suggest, or which one you can have idea about?
Paper adhesive like Fevicol and all.
Yeah, correct. Whatever the Fevicol and all are there, which contains your acrylic polymers. Okay, which we generally use for adhesive applications. So till now, four applications we have mentioned. One is like hard and rigid applications of your glass shields. Okay, then second is like adhesives. Third is like hydrogels, and fourth is latex paints. Correct. So these all are nothing but your applications of polyacrylates. Okay. So next is like properties of polyacrylates, which will come from your
Sir,
monomers.
one more doubt.
Yes.
So this polyacrylic is used in paints also. In
Yes.
paint, we are adding water to that. Whether it is also acting like a gel, it is.
No. It is completely different way. Whatever I have told you, it is completely depend on your molecular weight of polymeric system. Correct.
Mhm.
Okay. It will whatever the latex we are using in paints, it will
Hmm.
form a film,
Okay.
coating film over your walls. Whatever the painting we are doing, it is
Hmm.
nothing but the coating film. And that film is been there due to your polymeric system. Okay.
Okay.
Yeah. That is
But
nothing but the
we are
film
adding
application.
water and In the even the Asian Paints used to previously they have done some Kaizen or something. All the water was removed and only the latex is given and water is added by the this thing and the
Yes.
space that they have reduced.
Why they are adding water? It is dependent on your application type. Okay. If you are applying it through brush, then that kind of viscosity you needed. To control the viscosity, they are adding the water. Okay. If you want some roller type of application to your paints, then that kind of viscosity is required. So accordingly, they are adding the water part.
Okay,
Okay.
what
If
we
someone,
only
yes,
for
if
the application purpose. After that, it will dry
yes,
off,
yes, correct, correct.
and only the polymer remains on the surface.
Yes, polymer and whatever the other additive and other things are there, that will remain on the surface.
Okay.
Okay, if you are like, so suppose you want some spraying application. Okay, then high viscosity product you can't use, correct? You have
Mm.
to dilute it, correct? In that way.
Okay.
So your doubt is clear?
Yes, sir. Yes.
Okay. So next is like what all kind of properties or properties we will get from your monomeric systems. As I have just explained you all about now, like whatever, like see here, acrylic acid, methacrylic acid or itaconic acids. These are all nothing but the acid containing monomeric monomers, correct? These all can be used in your hydrogel or water, whatever the latex we are forming in that applications. Okay. Then amine and hydroxyl functionality, which are the like which one is the amine functional monomer here? Dimethyl aminoethyl methacrylate. This one. Can you able to see my cursor? Yes.
Yes, sir. Yes, sir.
Yeah. This is nothing but the amine functionalized monomer. Okay. Then again here hydroxyl functionalized monomer is there. This structure. Okay. This is structure. Okay. So dependent on your monomeric system, you will get the properties accordingly. Okay. So next is like, as we have mentioned some examples here, I have additionally mentioned some examples like major applications are coating, paint, textile, leather finishing, and tape adhesives. Okay, as we have now mentioned the examples of paint and coatings, adhesives, and leather finishes paints or paint, you can say in that way. Okay, some application include thickeners or flocculants, dispersants, and drag reducing agents, which generally used in your coating or paint systems itself. Okay, polyacrylates are also used as environmentally friendly adhesives or coatings. Okay, these are nothing but some of the applications. Okay, so
Yes,
here
sir.
in blue, drilling fluids have been mentioned. Have you seen this? Yes, these drill fluids.
Drilling fluid.
Yeah, drilling fluids. So these drilling fluids have applications of your hydrogels over here. Okay, hydrogels are being used in these drilling fluids. Okay,
Yeah.
so come back to the next application. It is nothing but your fibers. Okay,
Your voice is cut.
hello.
Now it's clear.
Okay. Just just take care of my that thing only. If you are not able to, just remind me. Okay, so in fibers there is application of your polyacrylates again. So which resin or which polymers have been used for your fiber application is nothing but your polyacrylonitrile. Okay, it is nothing but again the class of your polyacrylate system. Which one? Polyacrylonitrile, or we generally called it as a PAN in a short form. Okay, so polyacrylonitrile, like PVC, is insoluble in its own monomer. Okay, consecutively the polymer precipitation form the system during bulk polymerization. Okay, can you able to see in picture there is a fiber like structure. Okay, so acrylonitrile can be polymerized in solution
Is it
in,
fiber-like structure like that glass roving,
yes, or
but
glass rowing,
which we
or
are
you can
using in
say,
FRP?
yes, correct.
But it is looking like very smoothy. But
Yeah,
glass
yeah, yeah.
fiber is
The
not smooth.
texture you are looking like a smooth, correct?
But kind of
Yes,
that only. Yeah.
yes, yes. It is kind of a it's looking like as a glass fiber.
Okay.
Okay. So it is generally used in your FRP system or composite system. Okay.
This also we are using in FRP because that the glass fiber
Yeah,
reinforcement.
depending on your what is the requirement, you can say like, but what is the property you require in that way? Instead of glass fibers, you can use this. Okay. So acrylonitrile can be polymerized in solution in water or DMF. It is nothing but a solvent, dimethyl formamide, with ammonium persulfate as an initiator. This polymerization method we have already studied in our previous like starting slides. Okay. So generally, which monomer is used here? Acrylonitrile. Okay, to synthesize your polyacrylonitrile fibers. Okay, the polyacrylonitrile homopolymer can be dry spun from DMF directly from the polymerization reactor or wet spun from DMF into water. What it means? Whatever fibers you are making, it can be made directly by polymeric solution of your polyacrylonitrile. See, here the flow has been given here. Okay, can you observe this flow? Yes.
Yes.
Okay. So in very first step, whatever the solution of your polymeric system. Okay. Here for solution of polymeric system is there, and that will convert in your thread-like structure, or you can say fiber structure. Correct. That fiber will get cooled in this bath, and then again the next steps are been there to treat the fibers. Okay. Yes. Can you able to see this?
Yes, sir. Yes, sir.
Yeah. So this is nothing but your acrylonitrile monomer. Okay. This is the structure of your acrylonitrile monomer by which we will get your polyacrylonitrile over here. Okay.
Sir,
So this is
in this chain of this thing, where this particular thing is being used,
which one?
the above photo you have shared, and there is a
Yeah. This
block
is nothing but
diagram.
your fibers. These fibers you can
Output
use
or
in
input?
yes.
Is it an output or input?
This is output.
Output of this particular block diagram.
Yes. Yes. These are the continue fibers are there. These are fibers you are observing here. Nothing but the cutting part of your fibers. If you
Okay.
see,
But where from where it is being extracted, when we reuse, I think this will be used, or first time itself it is polymerized or synthesized in this form.
see, after polymerizing, obviously it will be in a solution, whatever I have mentioned here. It will be in a granular or solution form, correct?
Okay.
Depending on your polymerization technique. Okay. After that solution, you will get this kind of fibers using this technique, whatever the fiber making technique is there, correct?
Okay.
So this is nothing but the product, or you can say final fiber product, whatever is there in a picture.
Okay.
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 Yes. So this is nothing but you can consider it as a fifth example of your polyacrylates, which is nothing but polyacrylonitrile fibers. Okay.
Okay.
Any doubt is there in this application?
No, sir.
Okay. So what all properties are there for PAN or polyacrylonitrile? Okay. It is the most resistant polymer among all to degradation by sunlight, mainly by ultraviolet rays. So now just you have mentioned like UV resistance is there or not, but here in this polyacrylonitrile, it is UV resistant polymer. Okay, has the ability to form oriented fibers. Okay, it is quite inert and resistant to most organic solvents and acids, being only attacked by, I think, highly polar liquids and concentrated solution of bases. Okay. Its fibers are resistant to breakage, produce high volume, then are soft, as one of you have mentioned right now, correct? Comfortable and thermal insulating properties it is having properties similar to your natural wool. Have you seen natural wool?
Yes, sir. Yes, sir.
Yes, like that you can have the finishes of your polyacrylonitrile fiber. Okay, in the
And
form of
this
yes.
is not a natural product. This is
No, no,
a
no. This is synthetic one.
okay.
Yeah,
The two chemical is synthesized to get this one, or it is only one chemical.
one. See here, one monomer structure is given over here, acrylonitrile. This is the raw material to synthesis your polyacrylonitrile.
It will be in powder form. Huh?
Yes. Hmm?
Acrylonitrile. This is a powder form or liquid form?
It is in a powder form.
Okay, sir.
Yes.
As you mentioned, it's a substitute kind of a that cotton fiber, right?
Yeah, it is. Its texture is like wool fiber, or you
Mhm.
can say natural wool.
Natural wool. So
Yes.
the can we the cloth which we are making of natural wool, we can use this.
Mixture.
Okay,
Like
means we can say
in many of the woolen clothes, if you see in I think polyester class, I have mentioned that. Okay, if you have some synthetic like ester or you can say polyester clothes, okay, there is a mixture of polyester as well, like cotton and polyester mixture, correct?
Yeah.
Yes.
Yes.
Semi.
Again, I have secondly mentioned that woolen and your polyester, correct?
Okay.
In that way, there are fibers available with the mixtures only, correct? Natural plus synthetic. Okay.
Okay, so
Uh,
for this also pen plus wool kind of, right?
Yeah, correct. If you are having example in your textile application.
Okay.
Okay.
whether these things are decomposable, sir?
Obviously, if natural wool is there, it is decomposable or sorry, it is compostable, correct? If
Hmm.
this synthetic is there, it is not non-compostable.
Okay.
Okay.
Then there will be some way to at least dispose, no? Because when we read, we see that almost many whatever we are using are all converted to plastics.
Yes, correct.
Somehow it has to get before
Suppose they are
these
thermoplastic, then you can reuse it by whatever you have seen the applications like in I have mentioned in recent I think 2 3 lectures, correct? We can reuse it by crushing and then remolding again, correct? But
Hmm.
thermosets are not having that type of facility, correct? Thermosets we can't use again because it is having cross-link structure.
Okay.
Yes.
Okay, sir.
So in the form of fibers, when heated, it does not melt and maintains its morphological structure, a property that is used for the production of carbon fibers, insulating fibers, anti-flame or you can say flame retardant fibers and blankets. Correct? Which example is here? Blankets, which we just mentioned now, the mixture of your natural wool and synthetic polyacrylonitrile for the blanket application. Okay?
Yeah.
Yes. So all of you understand about the polyacrylonitrile, which is nothing
Yes,
but a
sir.
class
Yes.
of your acrylic polymers again.
Sir, the powder formed acrylonitrile is mixed with some solution, and that solution
No.
form it is
Yeah,
coagulate.
polyacrylonitrile you are talking about, correct? Yes.
Polyacrylonitrile in powder form is mixed with some
Polyacrylonitrile,
solution.
suppose it is in a powder or a granular form. Okay. If you
Uh,
want to prepare like fibers like this, then see here, last point I have mentioned, the polyacrylonitrile homopolymer can be dry spun from DMF directly, or you can dissolve in a DMF, making it solution, and then you can prepare fibers.
and what is this coagulation bath? Is that a water or is it any chemical?
It is nothing but some formulated thing, okay, which is
Okay.
again dependent on your required properties.
Okay. It does not have any relation with the this thing structure of our part.
No.
Okay. Okay, sir.
Okay. Okay. So again, some other properties of polyacrylonitriles are like it is a white solid, okay, with density somewhat like 1.1 kg per centimeter square in that way. Glass transition temperature is nearly approximately 95 degrees Celsius. Okay. melting point is nearly 300 degrees Celsius. It is insoluble in water, as we have just mentioned. It is soluble in DMF solvent, which is nothing but your dimethyl formamide. Okay. Then main solvents are like here I have mentioned DMF, then dimethyl acetamide, ethylene carbonate or propylene carbonate, sodium thiocyanate. These all are nothing but the solvents which generally used to dissolve this kind of polymer. Okay. Although it is thermoplastic, or you can say polyacrylonitrile does not melt under normal conditions. It degrades before melting. It melts above 300 degrees Celsius. If the heating rates are like 50 degree per minute or above. Okay. Then applications of it, like we have already seen, used for military purposes, used in aircraft body, okay, used in rocket motors and component to provide insulation, used in tents. It can be used in fireproof clothes. It is also used in as a electrolyte separator in batteries. Okay. Typical applications of acrylic fibers include your craft yarns, simulated for shirts, blankets, or whatever you can say. It is in a textile application. Okay. And also it can be used to make NBR, whatever the nitrile butadiene rubber is there. To make it, you can use it. Okay. Hello.
The ratio will be less, no, sir. Butadiene rubber,
Yes, it depends
nitrile
again
will
on.
be more,
Yes.
nitrile will be less.
Yes. Okay.
Okay, sir.
Yeah. So
But this
what are yes,
acrylic, actually, this is a acrylonit, no, nitrile, the previous slide,
polyacrylonitrile.
polyacrylonitrile, no?
Hmm.
Only nitrile will be used in the this thing, or this
No, 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 no.
polyacrylonitrile
This
can
this
directly.
whatever the monomer you are seeing here, acrylonitrile.
Ah,
This monomer have been used in that application.
okay, okay. NBR, it will be only that one.
Yes.
Okay, sir.
Okay.
Okay, okay, sir. Thank you.
Okay. So what all limitations are there for your acrylic
Can you
polymers?
go to back slide, please?
Yes.
That precursor for carbon fibers means.
Whatever carbon fibers you are preparing. Okay. To
Okay.
prepare that carbon fibers, this can be used. Precursor
So
means one of the raw material.
okay, like glass fiber. So
Yes.
simply carbon
Yes.
fiber are made through pen fiber, right?
Yes.
Okay.
By introducing some like whatever the carbon materials are there in like graphite
Okay.
or
And below this image, that is a thread of wool. It's looking like wool. So
yeah, the threads actually these are not the wool. This is nothing but your ropes. Whatever the ropes are there, correct?
yeah, the ropes we can make through pen fiber
Yes.
with the natural or with mixture.
With mixture as well, natural having less strength than your synthetic. Synthetic having more strength in that case.
Okay, means virgin having more strength. Okay.
Yes. Okay.
Yeah.
So what all limitations are there for acrylic polymers? Okay. The melting point for acrylic plastic is 160 degrees Celsius. So they can't withstand extreme temperatures. Acrylic is tough and durable, but can also be easily scratched. Okay. So this is one of the drawback for your acrylic polymer. Then the manufacturing process of acrylic products can be release highly toxic fumes. Okay, whatever the manufacturing is there for your acrylic polymers, as we are using acrylic monomers. Okay, acrylic monomers are more toxic, or it is highly toxic, you can say. Okay, acrylic is recyclable, however, as it's not biodegradable, the process is not as easy as putting it in your recycle bin or taking it to a bottle bank. Okay, it is not easily recyclable. Okay, order and flammability, obviously. Then acrylic sheets are cut, they tend to crack. Okay, cracking will be there. So these are nothing but the drawbacks, or you can say limitations for your acrylic polymers. Okay. So this is all about today's regarding acrylic polymers, its uses, applications, its overall properties. Okay. So anyone have doubt about anything regarding acrylic polymers?
No, sir.
All of your doubts has been cleared?
Yes, sir. Yes, sir.
Okay.
So is there any odor remover for this acrylic material?
Yeah, in suppose if you are having like suppose one of the application we can take here acrylic paints, correct? Acrylic paints having
Okay.
some sort of order in it, correct? So in formulation of your paint, they are using some pine oil. Okay, I am talking about only one application. Okay, they are using some pine oil to reduce the smell. Okay,
Okay.
so this kind of applications, if suppose you are having some plastic application, there are also some additives are there to remove the smell part.
Yeah. We are using for the PPs and all.
Yes, correct. I have just given one example of paint only here. Similarly, many in many of the examples, there are some additives being used. Okay.
Okay.
Yeah. Any other?
No, sir.
Okay.
No, sir.
So we will finish up with this acrylic polymers part here. Okay. Your next lecture will
But
be on, I think, Monday.
one small doubt.
Yes.
This sari and all last class we studied that all those things are made by this polyester and other materials, nylon like that. So
Yes.
in those materials, whether recycling is happening, whether people are collecting it back to the company for again
Yeah. If you
making
see in
them.
case of polyester, or you can only consider the polyethylene terephthalate PET.
Uh,
So nowadays, many of the companies are trying to recycle it.
okay.
Okay, because that processes or that sort of development is there already. So they are trying.
Then otherwise, what will happen to the saris and other things which only one or two times people are using it and then
Yeah,
all are
if
made
they
of
if that are
plastics only.
thermoplastic materials, then
Okay.
obviously recycling is there for so like by crushing it, then again remolding it for some sort of applications. But biodegradability is not there. That's why.
Okay, no biodegradable. It's
Yes,
not a biodegradable.
yes.
Okay, but all the polyester companies or nylon companies, they are taking it back and at least
No,
some
not
portion
all,
is
not all. Major parts are doing that thing only. Not all.
only virgin they are using.
Yeah, because property wise, it will not give the actual properties to you, correct? Whatever the reuse polymer we are using.
Okay, and
Yes.
PET bottle and all, we are marking that it is first time used, second time used like that. But
Yeah,
for
yeah,
fabric and
if
other
you are
things,
using standard form, then they are marking. Otherwise, no one will tell you that it is first use or second use.
okay, okay.
Yes,
Understood, sir. Okay.
yes. So we'll finish up with this part here, and on Monday's lecture, I think remaining part of your polyurethane and epoxy will be there. Okay, that will be the last class of last type of polymers you are having that day. After that, remaining syllabus will be there. Okay.
Okay, sir.
Yeah. Okay. Thank you.
Thank you, sir.
Thank you, sir.